Okay, so here's our review for functions, kind of a short little list of the things that you need to know. So make sure that you can plug in a value for x into a function. Make sure that you can plug in a value for y into the function and solve for x. Make sure you can do composed functions. So like a value gets plugged into some function g, and then you get an answer. And then that gets plugged into some function f. Or it gets plugged into g and then plugged into g again. Like you could string a whole bunch of them together. Make sure you know how to do domain and range, operations between two functions. So can you add two functions, subtract, multiply, and divide. And then when we do divide, we need to do excluded values. So excluded values is like restricting the domain. You're saying the things that x is not allowed to be. So if we move on to the first part, kind of goes back to stuff that we did back in Integrated 1 and Integrated 2, probably Math 8 and Math 7, where you were given function machines. So your teacher may have drawn like a little machine off to the side. And they said, okay, there's some function f that's being inside the machine. So there's so we'll just pay attention to. So whatever your function is here defined, so we have f of 2. So the function that would be inside is f. So if we put the f function in here, in this case, it was given to us as 3x squared plus 8. Hopefully looks familiar. The top is where you drop in some x value, and the bottom is where the y kind of pops out, which is the same as f of x. Hopefully this looks familiar. So basically, we look back at the notation, and it looks like in your f function, inside the parentheses, in the exact same location where the x is located in the notation, is 2. So basically, we're being told, wherever you see an x in here, you're going to plug in a 2. So all of those spots is where the 2 goes. So that's basically what that says. When we go through, and then at the very end, we say, okay, f of 2 is equal to whatever the value is. So I'm going to go through and do f of 2 off to the side. Everywhere I see an x, I'm going to plug in a 2. And then just make sure you obey order of operations. So we're going to do squared first. That's 3 times 4. And then we do multiply second. 3 times 4 is 12 plus 8. And then the last thing we have to do is add. So that's 20. So if we plug 2 in for the x value, what pops out the bottom is a 20 for y. This is basically what that says. So we can do the exact same thing for question number 2. So you take out the g function. Wherever you see an x in the g function, so see, look at the notation. Notice that the value that's given to you is inside the parentheses. Inside the parentheses in the g function is x. So everywhere you see an x, you're going to plug in a 6. Okay, so let's go back here. I'm not going to draw the function this time. You can if it helps you, but it's not necessary. So everywhere I see an x, I'm going to cram in a 6. This is going to be 2 times 6 minus 5. Obey order of operations. And then subtract. And this is just notation. All this is saying is that in the g function, when x is equal to 6, then y is equal to 7. That's what that says. It even says, like, on the g function, you have the point 6, 7. That's all it's saying. Okay, now the next part says you want to find x, so we don't know what it is this time. You're going to go to the g function, so make sure you pay attention to the function that's given to you. So we're given the g function, but notice the value that's given to you is not inside the parentheses. It's actually equal to the g function. So you're going to go back to the g function, and wherever you see the entire g of x itself, so g of x, the whole thing, g of x, that gets replaced with the value that's given to you. So this means that we're going to do -1 equals the g function. -1, because that's the value that's given to us here. So -1 is equal to, and the g function, which was 2x minus 5. You are solving for x. It's like your answer is x equals, because the question says find x. So go through, solve this. So now we're back in like math 7, maybe. Add the 5. So we get 4 is equal to 2x, and then divide x is equal to 2. So there's your answer. Now, if you need to write it in function notation, this is saying that g, because it's the g function, of the x value you just found, 2, is going to give you a y value of -1. So g of 2 is equal to -1. All right, take a look at the next one. We're finding x, so x equals is going to be the answer. For the f function, so go back to the f function this time. So this says f of x is equal to 20. So we're going to go to the f of x part. Let's go back to your f function. That entire left-hand side is going to be replaced with 20. So we're going to do 20 equals. And make sure you pay attention to the function you're supposed to be using. It is 3x squared plus 8. Solve. So subtract. That's going to give me 12. Divide. That's going to give me 4. Square root. Remember, whenever you square root something, you technically get two answers. You get a positive and a negative. So we're going to do plus or minus square root of 4 is equal to square root of x squared. You only need to put the plus or minus on the side that has the number on it, and you don't need it on the right-hand side. So over here, those are going to cancel. This is plus or minus square root of 4 is 2. So x is equal to plus or minus 2. So basically what this says is that in the f function, when you have an x value of -2, so I'll pull these apart, this is going to give me 20. But you also have f of +2 is equal to 20. So if I look here, this plus minus, there's the minus, there's the plus. You can push them together, so it's f of plus or minus 2. That's totally fine. Looks kind of weird, but you're welcome to do that. There's nothing wrong with that notation. So just make sure that you pay attention to what it is that you're supposed to be solving for. Okay, so now instead of being given like f of x equals 9x minus 23, whatever, instead of given an equation, you can be given a graph. So just a reminder that we're still talking about x's and y's. That's ultimately it. So if we take a look at this guy, this very first one here. So question number 5. So I've defined f of x. It's on the graph. This is saying we want to find f of -2. Figure out what that is. Well, remember, if something is inside the parentheses, it is going to be an x value. So basically, we know the x value is -2. So I am going to go to -2 on the x-axis right there. So I already know what the x is. My job now is to go up or down, whatever direction you need to do. Don't go right or left. Those are x's. Go up or down so that you can find the corresponding y value. So you're looking for the point -2 comma what on the graph of f of x? Well, it looks like I have to go down to this point right here. So the question is what's the y value there? Well, the y value there is going to be -1. So my answer to this one is I have an x that's -2. I'm trying to figure out what the y is. So I know the point is -2 comma something on the graph. Well, the something is the one we just found. It's -1. That's it. That's it for this one. If we go to the next one says, okay, we want to find x. So we don't know x. We're trying to figure out what that is, which means we know that f of x equals 0. Remember, f of x is the exact same thing as y. So this says y is equal to 0. So I'm going to go on my graph to where y equals 0. Well, y equals 0 is on the x-axis. So right there, I'll put a little dash there. This is where y is equal to 0. But I'm looking for x's this time. So I need to look right and left. I'm trying to find the points on the graph, and in this case, they are plural, where I have something, comma, 0. That's what I'm looking for. So on my graph of f of x, I need to look right and left on the line y equals 0. And it looks like there's a point right there. That x value is going to be 1. And then there's a point over here. So if I go 1, 2, 3, 4, 5, looks like that x value is -5. So what this says is that I'm going to get x is equal to, well, 1 was one of them, and x is equal to -5. If you need to write it in function notation, which your teacher might require, then basically what we're saying is f of 1 is equal to 0 and f of negative 5 is equal to 0. Just so happens that there's two x values. You can have no x values. You could have 1. You could have an infinite amount of them. So there's multiple locations where you could have a y value of 0, depending on whatever the graph looks like. Okay. And keep looking back at this function itself. We want to figure out what the domain is. Well, remember, domain goes from left to right. So if I take a look at this, I can see that this graph, so the far left, I can't really trap the graph in. I've got these arrows pointing on the left. So that means that this arrow, although yes, it's slightly pointing up, it is pointing left forever. And then on the right-hand side, the arrow is pointing, yes, up, but also right. So I'm going to go right forever, which means that my domain can be written a handful of different ways. You can say that this is negative infinity, furthest to the left possible, positive infinity, furthest to the right possible. Make sure you put parentheses around it. Don't put brackets on it. It doesn't make any sense with infinity. You could say negative infinity, and we're talking about x values because we're talking about domain, and that x is basically trapped in between negative infinity and infinity. So all possible x values, furthest to the left, all the way up to the furthest to the right. This is another way to write it. Or if you have negative infinity, infinity, you could also just say all real numbers. Well, there's a symbol for that. So it looks like a capital R. So it looks like that, kinda. But it has 2 vertical bars instead, and then just draw your R over it. It's not like IR. 2 vertical bars, capital R. Okay, then range. Take a look at the range, and we want to see how far down is this graph going. So it's always small to big. So how far down? Well, this one clearly has a low point. It doesn't go lower than that point right there, which means it's going to start at negative 1. But remember those arrows that we had pointing to the right? Well, they're technically pointing up as well. So this one is technically pointing up, and so is this one. Even if only one of them was pointing up forever, that supersedes anything else that's already happening at the other point. So it's going to keep trucking. So I know for range, I could do negative 1, comma, forever, up. Remember, infinity never gets brackets. Negative 1's going to get a bracket because the graph actually hits at that y value. So this is one way to write it. You could do it the same way with the other one here, just like we did with the domain. Never put an equal to on infinity. That doesn't make any sense. If you have a bracket, that means it's actually hitting at that point. So you need the or equal to for the negative 1. You can't use the all real numbers. That you're not allowed to do that because all real numbers is negative infinity to infinity. So it's basically your 2 options. Yes, there are many ways to do this. That's 2 of the ways. Okay, question number 9. 9, 10, 11, we're going to use the set of points here to the left-hand side. So actually a good point to take a look at. If we take a look at the very first graph, up at the very top that I defined as F, notice that if I were to, very basic definition of continuous, very, very, very basic. If I were to take my pen or pencil or whatever it is that I was using to try to draw this graph on my paper, could I trace through the entire graph of f of x, so the one that I just went through, without lifting my pencil off the paper? Let's test it out. So I'll come in here with running out of colors. Let's do red, like red. If I were to come in here from the left-hand side, let's see if I can trace this whole thing without lifting my pencil off the paper. And you don't have to double it back. I'm just trying to make it a little bit darker so you can see. So I can trace this whole thing without lifting my pencil. If I can do that, then I would say that this is continuous. So if I can trace it without lifting my pencil, super basic definition. When you get to calculus, they'll give you more. That means the graph is continuous. Now, if I take a look at the new one where I have questions 9, 10, 11, can I do the same thing? Can I, and I'm going to use a red pen again, can I go through and no, I can't. I have to pick up my pencil, kind of jump my way over here with my pen to get to the next dot. Jump my way down here to get to the next dot. Notice I'm having to pick up my pencil or pen, whatever it is that I'm using to try to trace this thing. If it is not that case, and again, very basic for us. So if it just looks like a scattering of dots, we would say that this graph is discrete or not continuous. Discrete is what you're going to hear from us, though. So this graph is discrete. Kind of goes back to when you did line of best fit, scatter plot type stuff in integrated 1. It was just dots. You didn't actually connect the dots. So keep that in mind here. We're not connecting the dots here at all. They're just dots. So when we're describing domain, so just domain on this one, domain is all the x values. Well, because it's not continuous, you can't say -5 to 3 because there's all the fractions, all the decimals, all of everything in between those things. And that's not the case here. These are just specific x values. So if I go and look, I'm only going to mark the ones where I actually have a point. So that's at -1. I'm not going to put -2 there because no point there. -3, -4. I don't have one at 0. 1, 2, 3. So the ones that I labeled, -4 is not on there. Let's get rid of that guy. Oh, yes, it is. Good gravy. Okay. So I have points at -4, -3, -1, 1, and 3. So my domain is just those things. I just have to list them out. So I'm going to I'll leave a little bit of space in front. So it's -4, comma, -3. You actually have to list them. -1, 1, 3. There's no decimals, no fractions, no nothing. You can't say, oh, it begins here and it ends there. That's not true. The way that we do this when we describe domain specifically, if it's discrete, is it's a list and then you put the little curly braces around it. That's domain. Range, I'm going to do the exact same thing. So with range, I'm going to go through and I'm only going to label the y values that are used. So let's see. I do have a point up at 1, not at 2. I'm not going to label it. Yes, at 3. I do have a point at 0 because it's this guy way over here. -1, I do have a point. And -2, I do have a point. I don't even have any points below that. That doesn't matter the order that you list it. I did small to big previously for domain. I'm going to do the same for range, just kind of a habit that I have, but you don't have to. You can just list the numbers in whatever order you want. So I'm going to go -2, -1, 0. Again, it's just a list, 1 and 3. And then put some braces around it. Okay, function. All right, so determine if something is a function. You need to see if it passes the vertical line test. So basically, if I went through and I just graphed vertical lines through all of the points, you want to make sure that no 2 points land on the same line. So that -4 point's good. There's only 1 point on that line. That one's off a little bit. There's only 1 point on that line. I don't have a point over there. There's only 1 point on that line. I'm good. There are 2 points on this line. This is not good. So if you have multiple points hitting on a vertical line, that means this is not a function. It fails the vertical line test. So function, no. Make sure you can describe why. You can say fails vertical line test. You can say that the x value of 1, so x equals 1, has multiple y values. So like 1 comma, what do we have here? 1 comma 1 and 1 comma 3. There's many ways to describe this. So the bad news here is that you absolutely cannot have the exact same x value with different y values. That means it failed the vertical line test. Okay, moving on. So we're going to do composition of functions. Basically, just to start deep, what this says is that if you go deepest inside, we have this value of 1 here. That's going to be an x value. So this value is x. Where do we plug it in? Well, you plug it in to the very first function that neighbors it. So we're going to go to g. Notice that g is closest to that set of parentheses where the 1 is located. So we're going to go to the g function, this guy right here. Everywhere I see an x, I'm going to cram a 1 into it. So the first thing I'm going to do is I'm going to do g of 1. So start deep. I haven't even looked at the guy on the outside yet. G of 1. So I'm going to go to my g function. Everywhere I see an x, I'm going to cram a 1 in. And then I'm going to do the math. So g of 1, that's 2 minus 5. That's equal to negative 3. Okay. So if g of 1 is equal to negative 3, then what I can say, I can actually rewrite this guy at the beginning, is that I have f of, well, g of 1 itself, I just figured out was negative 3. So I'm going to replace it. So this now says f of negative 3. So plug the value in that we just found. Okay, now you're at the next function, or whatever the next function was supposed to be. In this case, it's f. So now we're going to go to the f function. And everywhere you see an x, because that's the new x value inside the parentheses of the function, you're going to plug in a negative 3. So now this says, we're going to grab the f function. So 3, there's my x squared plus 8. Plug in the x value. Follow order of operations. So this is 3. Negative 3 squared is 9. And that's 27 plus 8. This is going to give me 35. So what this says is if I take 1 and I cram it into g and get an answer, and then I take that answer and I cram it into f, I'm going to get 35 at the end. That's what that says. So 1 goes into g, that answer comes out, that's my new x value, that gets crammed into f. Same thing with the next one. You just pay attention to the function that's the closest. So I have my x value of 0 because it's inside the parentheses. Who's it next to? It's next to the f function. So what I'm going to do is I'm going to do f of 0. So I have f of 0, go to my f function. Well, my f function was 3x squared plus 8. So 3, there's the x squared plus 8. Do the math. 0 squared is 0. 3 times 0 is 0. 0 plus 8 is 8. Okay. So now this says that I have, well, f of 0 is 8. But now you have to plug it into the next function, which is the g function. So g's next. Notice I'm working my way out. If I had an h function and it was next, I'd keep going. So now this says, okay, go to the g function. Okay, so I'm going to go to the g function. G function is 2x minus 5. So 2x, my new x is 8, minus 5. So it's going to be 16 minus 5. 16 minus 5 is 11. So basically what this says is I'm going to take 0. I'm going to plug it into my f function, get an answer. That answer is the new x for the g function. When I do that, I get an 11 at the end. Okay, operations between functions. It really is as straightforward as it looks. So if you were asked to take h of x, so the whole function h of x, don't plug anything in for x, it doesn't say to, h of x, which is 9x minus 13, and k of x, which is negative 2x plus 1, and it wants you to add them, then add them. Just combine like terms. You don't have to do anything crazy here. So I'm going to take my h of x function, and I'm going to replace it. H of x is 9x minus 13, so I'm going to go, okay, h of x, you're out of here. 9x minus 13 in place. Plus, if this is plus, I am not going to use parentheses when I plug the k of x in. If it was subtract, I definitely would. So then I'm just going to copy k of x down, negative 2x plus 1. All right, step 1 done. No, just combine like term. Put the x's together, that's 7x. Put the constants together, that's minus 12. That's it, you're done. Don't do any more with it. There's nothing to do. Definitely don't put the 7x and the 12 together. That's bad. Okay, so now says, okay, k of x plus h of x. All right, this looks familiar. K of x, replace it. Negative 2x plus 1. Plus h of x. All right, 9x minus 13. Combine like terms. 7x minus 12. Notice that if you are adding two functions together, and they're the exact same two functions, notice I used h and k for both of them, you're going to get the exact same answer, for sure. It doesn't matter which one comes first or which one comes second. It's because addition is commutative, which means the order doesn't matter. So like 2 plus 8, we know is 10. 8 plus 2, so I just switch the order, also 10. Nothing happens. So the order in which you add things, it doesn't really matter. Okay, let's take a look at multiplication. All right, since it's multiplication, I'm going to replace the h of x and the k of x, but I'm using parentheses because multiplication requires a little bit more work. So h of x, 9x minus 13. Multiplication dot, so I still have the operation, parentheses, k of x. K of x is negative 2x plus 1. Okay, multiplication dot, totally not necessary. I only put it there so that we could see the continuation from the question. So now, multiplication dot, I can just drop it. And just kind of smush these two together. Negative 2x plus 1. Okay. This should look familiar. You spent a ton of time doing this last year. Draw a box. Or foil, whatever you want to do. Or just distribute. Totally up to you. Doesn't matter. So if we use the tools that you have used before, I would go through and I would draw a box. I use the first set of parentheses as my base, typically, not all the time, but typically. And then the next one as my height. And then go ahead and fill the boxes in. Combine like terms. So I'm going to get negative 18x squared. Put the x's together, so that's going to give me 35x. And then my constant, minus 13. That's it. Don't do anything else. Don't factor. That just sends you back where you were. Like, I don't want you to create math for me to do. I want you to do all the math. That's ultimately it. Okay, so let's take a look at the next one. K of x. K of x, so let's replace k of x with negative 2x plus 1. Times h of x. H of x, 9x minus 13. This should look familiar. Okay, let's look. If I have multiplication, actually, we can just get rid of the dot. Let's get rid of that. That's not necessary. Multiplication, just like addition, is commutative. So if I have k of x times h of x and h of x times k of x, it's kind of like 7 times 4. That's 28. 4 times 7. Notice I just switched the order of the 7 and 4. Also 28. So if I take a look at this order of 9x minus 13 and then the 2x plus 1, there's the 9x minus 13. There's the negative 2x plus 1. I'm going to get the exact same thing. They're identical to each other. So multiplication, commutative. Change the order, it's totally fine. Addition, commutative. Change the order, totally fine. Get the exact same answer. The next two, no, they're not commutative. Subtraction, it matters the order that you subtract. Like 10 minus 2 is 8. 2 minus 10, that is not 8. Not even close. So the order in which you do subtraction definitely matters. So you got to pay attention here. And actually, whenever subtraction's involved, I'm going to use parentheses when I plug stuff in. I think it makes it a little bit easier. So h of x, 9x minus 13, minus parentheses. I'm only going to put parentheses around the second thing. So the thing that is being subtracted, which is going to be negative 2x plus 1. Here's the reason why I do that. Because you are subtracting everything in the second function. You have to distribute that minus sign. Everything gets subtracted, not just the first part. So I'm going to drop down the 9x minus 13. If I distribute, that becomes a plus 2x and then a minus 1. Now it's addition, combined like terms. So this is 11x minus 14. So that's h of x minus k of x. Okay, let's test the other one, k of x minus h of x. So negative 2x plus 1 minus parentheses. All of the second function, 9x minus 13, is going to be subtracted. Distribute, drop down. Negative 11x plus 14. Let's look. These are not the same. They are not the same. You have to be very careful with this. It's like you're subtracting the entire second thing. Don't not use parentheses. It might blow up in your face. It's not a good thing. Okay, so just be careful. All right. Division. So I'm just going to plug things in where they go, which is exactly what I've been doing. So the h of x function is 9x minus 13. H of x is on top, so 9x minus 13 is on top. K of x function is on the bottom. So put the k of x function on the bottom. At this point, to simplify this, there's nothing you can do. Like, don't even try. The only way you could do it is if you can create factors. We'll get to that later. This cannot be simplified. However, this is the first time in all of the operations that I've done so far where I now have an x in the bottom of a fraction. Well, if I don't give people limitations on things, you can plug in whatever you want. Like, I really like 0. I love plugging in 0. It's my favorite number. So if I plug in 0, am I allowed to do that? Well, yeah, I think so. The 9x would cancel and the negative 2 would cancel. I can plug in 0. That's fine. I get a real number as my answer. The problem is if somebody plugs in a number and you end up with 0 in the bottom of a fraction. That's no good. So what we need to look for, and it only comes from the bottom of the fraction, just the bottom. Negative 2x plus 1 is absolutely not allowed to be 0 because we don't know how to divide by 0. So I'm going to I'm going to solve this equation, this not equation. I'm just going to solve for x here. So I'm going to minus the 1 to the other side, just like I normally would. I'll get negative 2x cannot equal negative 1, 0 minus 1. I'm going to divide by negative 2. X cannot equal a half. Because if I plug a half in for x into all of the x's, it's fine if you get 0 on the top of a fraction. There's nothing wrong with that. That's just 0. But if you get 0 on the bottom of a fraction, that's undefined completely. We don't even know how to do that. So this is called an excluded value. So excluded value is x equals a half. X equals. As soon as, actually here, let's get rid of what that is. The excluded value is x equals. When we say not equals, this is called restricting the domain. Basically saying, hey, here's my answer to this problem. You can plug in whatever you want, just don't plug in this, because that's bad news. So I'm going to go back up to my fraction, put a little comma at the end of it and say, okay, x, whatever the variable is, cannot be a half. I'm going to give them the restriction. Plug in anything you want, just don't plug that in. That's bad news. So the answer to this is this whole thing. It's the fraction where you put the two functions where they belong, comma, the excluded value, the restricted domain. X cannot equal. We do the same thing with 21. So k of x goes on top this time, negative 2x plus 1. H of x goes on the bottom this time, 9x minus 13. I have an x in the bottom. You're going to have an excluded value. X cannot equal. Okay, we're just going to do a little bit of work off to the side. Take the denominator. It is not allowed to be 0. Okay. Add the 13. 9x cannot equal 13. X cannot equal 13 over 9. Just leave it as an improper fraction. That is your domain restriction. This whole thing is the answer. So it is fraction with the things put in the right spots, comma, restricting the domain. Like, you cannot do this. Looks like that's the end. Hope this helps.